carry on.
Okay, so yeah, we've got our processes and specific routes helping with the problem solving, the efficiency and training. We also have the booth laid out in a certain way so that we have the paint lines are 3 foot above ground level. The paint lines are connected into the wall. There are a series of lines. You have primer lines, base coat lines, clear coat lines, which are all colour coordinated to ensure that you pick up the right line. These are hung on the wall at an optimum level of 4.5 foot off the floor. So you can just walk in, pick the line off the wall, and you walk to the end of the booth. As you walk into the booth, there is a shadow board on the wall with colour-coded guns, so you can pick up the correct gun. However, before the spraying process, there is other processes which I'm going to go into a bit further down. So we're talking about the booth and the spraying, just to be clear. I'm going to speak a little bit about the environment of the booth because I can't picture it here. I haven't got a picture of the booth, so I'm going to speak a little bit about the environment so you can sort of picture where we are. So the booth itself is around 60 foot long by 25 foot wide. As a downdraft, so the whole roof is an air intake and the whole underneath the floor, so it's a gridded floor, and the underneath that is a waterfall. The air coming through is around 37,000 cubic metres of air moving through that booth at any one time, so you can imagine the strain on the guys' joints, legs, you tend to feel it if you're in there for a long period of time. With that in mind, the sprayers process around 5 to 7 minutes per application, and then you have a 15-minute breather while the robots paint their bit and do all the loading and purging and moving of the body. So for every 20 minutes you're only working 5 minutes of that. Through the centre of the booth there is a 50 foot by 5 foot wide conveyor, which is basically just a big box which the car runs in and out of, with steps all the way around that to ensure that the guys can get up and down the conveyor with ease. The lighting in the booth is a minimum of 3,000 lux in any given area. This ensures that the sprayers, whatever area they're standing in, they can see without shadows of what they're doing, and it's as close to natural light as possible. So there's a mixture of yellow and white LEDs just to give us close to natural light as we can get. Noise-wise, we do lots of noise testing in the area. So every 6 months we have our health and safety team come round and they do noise testing. Obviously with compressed air, makes a fair amount of noise when you pull the trigger, and with the downdrafts that are constantly running we have to be a little bit careful. However, on average the booth makes a constant 60 decibels, and when static and when you're spraying you get around 86 decibels. So we don't need hearing protection because of the exposure time that they're in the booth. However, there is a cupboard with other bits anyway, so it sort of absorbs the noise a little bit. So back to the body when it's in the booth. So I've just mentioned a 3 foot conveyor from the ground level. The car's on top of this conveyor. This is for 2 reasons. Firstly, the robots, obviously they can't paint on the floor, and secondly for the manual sprayers. So when the car comes in, it tends to be around this sort of level and they can spray the whole door shut with barely reaching. So there's always a bend in their arm, they're never really stretching out of place. The doors are opened wide enough that they can walk in between the 2 doors to do the whole door shut with ease. Okay, so I'm going to move on a little bit, and there's a bit about the process and the environment. Man-machine interfaces. So I spoke about going into the booth, and before we start the spraying process itself, the guys actually run the area. So they control a back-off, we call it a back-off. It's basically a touchscreen screen which controls all aspects of the application booth. So this controls the robots, it controls all the conveyor movements, it controls the loading and purging of the paint into the hand and robots, into the hand station and robots. It has all the alarm and reset functions, manual overrides and valves within the booth, so you can open and close and get material off if we need to do some material testing, and it does the booth parameter monitoring. So the booth parameter monitoring is all about the temperature, humidity, downdrafts. We have specific limits that we're allowed to work within. Nominal is 22 degrees. If it goes over 24 or under 20, then we stop spraying completely, and sprayers aren't allowed in the booths. The benefits of having the interface that we have is it's fully hydraulic, it has full hydraulic adjustability to suit all characteristics of people. It doesn't matter if you're short at all, it's literally a really light, easy movement of the screen, and it holds itself in position. It's a touch screen or a rollable, depending on what you like to use. It's full colour coded screen and buttons depending on the material you're loading. So if you're loading primer, it will be yellow. If you're loading base coat, it will be red, and if you're loading clear coat, it will be green. So you can only touch the buttons of the car that's in, and it will all light up and show you the way through the has visual and audible alarm systems for the booth, parameter deviations, so it won't just stop and not tell you what's going on. It will come up on the screen and tell you what's out of specification, what you need to do about it, and it all has follow-up actions built into the system. And by having all the movement, it eliminates the fact that you've got to move around to get to the screen. It's literally placed right next to the booth door, so you literally just pull the screen out, punch in whatever the car is, and carry on. Ergonomic design, ergonomic and layout features of my manufacturing situation. So the body, as I spoke about, is at a nominal height when spraying. There's no leaning. You have to bend one slight bit when you're doing the bottom of the door, depending on your height. However, if you're slightly shorter, we have steps that you can put in place so you can climb up and do the tops of the door shuts. However, they're very rarely used. We seem to have an average height of people at around 5.5 foot to 6 foot, so they seem to be able to paint the whole door shut comfortably. The wall connectors, as I said, are at a nominal height. The steps that we have in the booth are detachable, so for cleaning purposes, or if someone wants to move the step up the grid a little bit, depending on the model, then they can move the step as they wish. The shadow board I spoke about at the beginning of the booth next to the door is just nice and easy. There's no walking to go and get it. You load up the booth, you open the Fortress locking system, and you go in and your shadow board's right next to you, so there's no unnecessary movement. And obviously we spoke about the optimum lighting for the manual sprayers. Health and safety wise, there's the pressure guns that we use. There's two types of gun in general. You have a pressure fed gun, or you have a gravity fed gun that has a pot of paint on the top of it. The issue with the gravity fed guns is firstly they're really heavy when you're trying to go around the door shuts, or trying to use them in general. You have generally about half a litre of paint on the top, and you tend to run out and create spits and deviations within the finish. So we use pressure fed guns. These have an additional line that plug into the bottom of them. However, it's a consistent flow of material going into the gun, ensuring that we don't have issues with the material. And also it's probably about half the weight of a gravity fed gun, meaning for their 5 minutes of going around the door shut, they're not aching their arm, they don't suffer with weight or strain injuries. It's a much better process. Probably the most important part of the next two is we have interlocking doors that separate the man from the machine. So the interlocking doors are done by a Fortress locking system, so you can't get in the booth without undoing this door lock. This door lock overrides everything else in the plant, or everything else in our area. So this door lock overrides the back-off screen where it does all the loading. If you open that door, it just stops everything. It's almost like an emergency stop for the booth. Our booths with the robots run 40,000 volts of electricity for the high voltage applications. So obviously we can't have people going in there with that sort of voltage running through it. And secondly, we have full air-fed masks and body coveralls. So you tape your gloves to your overalls to make sure that you can't get any paint onto you. Obviously isocyanates will go through your skin and cause issues.
How do you accommodate the time it takes for people to get suited up to go in to do their work? That's part of the cycle time, is it?
The screen tells the guys which car's coming in next, so they know which booth is coming in, which car, which model, which colour. While that's coming in, they'll suit up and get ready while the transfer time's happening. And then when it comes in, it will flash up on the screen and say, it's this colour, this. You just confirm that what it says is correct, and then carry on. And by the time the paint's loaded, so we have a loading time as well of about 4 minutes. So they'll hit the button and confirm that the paint's correct and that the paint's on the system, and it does all that for them. All they do is just say OK. And it's 4 minutes from that point. So as soon as it's done its loading, there's a green flashing beacon that says it's loading. As soon as the green goes solid, you're good to enter. And then you can go in and you can do your process. You then come out of the booth, lock the booth back up with the Fortress locking door, hit the button, and the car will move to the robot zone. From that point, it's completely automatic. The car will then finish its robot cycle and release itself into the ovens and coolers. That's a pretty cool bit. The features to support these, why the features support the operators, obviously they have minimal stretching and bending due to the majority of the shuts being in reach. The steps ensure that that 3 foot conveyor is only half of that, so it's about just over a foot of step to help you up onto those. The lighting ensures that they can see the shut regardless of the angle, the shadow boards, as I spoke about, and the lightweight guns. So lots of features that help the operators do their daily work. The layout design of the workplace. So the booth is designed to be clear of space and clear of anything in anyone's way, including the robots. So the booth, if you walk in, I spoke about the 60 foot wide by 25 foot, 60 foot long by 25 foot wide. There is literally nothing in that whole floorway apart from the conveyor in the middle. Everything is kept either in behind the walls of the booth, so all that sticks out is 3 little lines about that long, and then you have your lines on the wall. So there's literally nothing that can be in their way. The only trip hazard is when you're painting, you have the lines that you pull around. So the lines that you spray with, you have 3 of them, 1 connected to your air-fed mask, 2 connected to the gun. You tend to just pull them around with you. We looked at having systems put in place to hold the lines, but they just created more dirt and issues than we had before. And the maintainability of such systems was just a pain. So having the reels built into the wall, the paint line would pop off the reel on the inside and fill the outside of the booth up with paint, and stop the booth for sort of an hour at a time while we cleaned it up and got everything sorted out and the lines back on. So we've just gone back to having lines that you pull around the floor and just ensure that people are aware that they're there. And I haven't had a single accident in the last 48 months of people falling over lines or tripping on those. My issues tend to be people sticking to the grids, which we know that we've got to clean them pretty quick. Got that in it. And the booths are flexible to accommodate any model of car, any characteristic of any person within reason. So we've had a one-arm sprayer, and he's probably one of the best sprayers I've ever had. That being said, if you've got no legs and you're in a wheelchair, you're probably not going to be able to paint a car for us. So I say within reason. So 6, for relevant information or data from our manufacturing situation. We use things such as spaghetti diagrams in the layout planning, so we can improve our work and ensure that we're walking around the correct ways. We didn't used to have the shadow boards, as I discussed earlier on. They used to be hung on the wall, along the whole wall, and they weren't colour coded and they weren't in the correct location. So you'd walk in, you'd be trying to figure out which is the correct gun. So using spaghetti diagrams, that led us into the fact that they were walking, but it also drove us up the path to the fact that everything was just confusing. Lines weren't colour coded, every line was green. So now the screen that I spoke about, having the red primer, the yellow base coat and the green clear coat, it's exactly the same with the lines within the booth now. They're the same colours, so you can always, you know what you've just loaded, go and grab the same colour in the booth. So that works really well for us. Process observations is used as a method study to improve the process and ensure that processes are free from waste. So a lot of the time we'll tend to see people, I don't know, within the process using excessive materials, or they'll have way too much material on their side, or they'll be moving around way too much. So one of the areas we have is a cleaning area and it has a lift within it, and the guys just weren't using the lift. They were just leaning on the door and washing the bottom of the car. So with the Gemba standards that I discussed earlier on, we can now lift the car up, make sure people are lifting the car every time, and they'll save their own bodies as well as giving us headaches. And then for productivity improvement, we tend to use value stream maps. So using a value stream map, we used to have 2 spray booths and a masking box. Using value stream maps, we came up with an idea to get rid of the masking box and implement a 3rd spray booth in that location, which is what we have today. And using value stream map and a little bit of simulation, we managed to show that we could almost treble what we were putting out work-wise. I think that works out right. Something like that. Anyway, we had 12 units per day with the 2 spray booths and the masking box, and we knew that on the horizon was going to be 16 to 20 units per day. So we started doing value stream maps, trying to figure out where we could save time, try and improve the process and make it work for us. It turned out that the masking box was actually a dead zone. The masking box was just a place where the car went in and came back out and went pointlessly into the spray booth. So we went for a period of time where we switched the masking booth off and took it out of our tracking situation, and we just used the spray booth, so the car would come straight out of the cooler into the spray booth and get painted again straight away. And we improved our situation tenfold. We now have the 3rd spray booth built, and we were hitting 24 cars a day, maximum 22 with relative ease. So the 3rd spray booth put us over what we needed. However, when I move on to the future state situation in a minute, you'll see where it's sort of going or may go. So outlining techniques suitable to analyse manufacturing situation. So during the day we have a collection of data for our productivity. We use an hourly layer tracker within our application booth. So the sprayers know exactly what they've done throughout the day. They know how many cars they've painted personally, and we know how many cars have been in and out. We know which cars they are. We know if they're 2-tones, if they're monos. You can see everything from this little piece of data. However, at the same time as it's calculating the numbers and where we are, and it's calculated to the plan, it also has what issues went wrong and what are we doing about it to fix it. So this sheet actually gave us the ability to fix one of our major issues, which was gun boxes in the workplace. So our gun boxes is the sprayers would go in and the gun would be in a box. Basically, it preloads the paint for you. You just hit the button and it preloads it for you. But the gun box kept tripping out, and we didn't really notice it until we implemented this sheet. And with this sheet in place, we noticed that every day we were losing around 15 minutes just for this gun box. So we've set one of our maintenance guys a little task to get rid of this issue, and what he actually done was got rid of the gun box completely. So you now unplug your line from the base coat gun and just plug it straight into the wall. It instantly decreased the loading and purging time, so it used to be around 8 minutes. I spoke about it a minute ago, it's around 4 minutes now. So basically it used to use the gun nozzle, which is about 0.8 of a millimetre, and it now uses a 8mm internal diameter pipe just to fire it out. So much quicker, it improved our process time, and it got rid of the issue that we have, and we've not had a single stoppage through base coat lines loading again. So it worked really well. For processes, we have our work instructions and Gemba standards, which I spoke about. That's part of a Gemba standard there, but there's also a lot of data behind it. So work instructions will give us what we need to do, and the Gembas are giving us how we need to do it. And it's very specific with every part of the situation. Every part of the process is documented. You literally cannot go off-piste if you wanted to. And if you do, we have plenty of Shell 1 and Shell 2 operatives walking around that are process confirming people daily, ensuring that people aren't doing what they want to do and they're doing it the way it needs to be done. And then I spoke earlier about the noise testing, ensuring, so part of measurement was noise testing and ensuring that all the areas are within set limits, and ensuring that those areas that go slightly over, depending on the exposure time, wear hearing protection. The next bit I've got to summarise on the impact of the improvements derived from the techniques, which I apologise for because I've already done it on the last bit, which was the hand station.
So maybe summarise what your future state is. That you
Okay, so
get to,
future
yeah.
state-wise is unfortunately to not use manual sprayers. So the future state as it stands, as you can see in this picture, consists of 4 robots mounted at high level, which are manual handling robots solely. They will come in and open and close the doors, which will be done by a camera system. So it'll take a picture of the car, tell the robot exactly where the car is and where the doors are that it needs to open. The robots go in, they open the doors, and then we have 2 additional paint robots. These paint robots will be the robots that go in and do the internals of the door shuts. So essentially, there will be no manual spraying. So that is our future hypothetical state. I say hypothetical, it's
Yeah, but
being implemented.
so the long-term issues there is obviously you remove staff from that area. But what if
utilise stuff
yeah. So you remove staff from that
from
area.
that area? Yeah.
But what happens if business takes a downturn and you're doing less cars? You can't remove the robot.
Can't remove them. We'll just carry on and we essentially just slow the robots down, and it would give us, at the minute we're running 3 shifts, so we could stop a shift with ease and give us more time for maintaining the area and the equipment.
And in all of this automation, which again sounds wonderful, and that, how do you factor in maintenance of the actual machines and the automated systems?
So we have
as well?
set PMs, which is productive maintenance, preventative maintenance, and we have TPM that goes on daily by the guys. So essentially, all the booths create natural gaps. So depending on the times it takes to paint certain materials, a primer car will take around 15 minutes, whereas a base coat car might take around 25. So they all end up running slightly out of kilt, which means you might have a 10-minute gap in one booth. So we look at the TPMs throughout the day, and we assign which ones depending on the time saved that we can put in each booth. Then we have a night shift on, so the ones that don't get put on through the day, or completed through the day, we'll stop a booth for the night shift and we'll complete all the PMs and TPMs for that day, that night. And we have cleaning activities between every booth, which is where they also inspect the robot. They take the cover off the robot. It takes about 45 minutes per booth. They'll quickly whip the covers off, make sure all the pipes are okay, there's no leaks, there's no air leaks and stuff like that, just ensure it's all correct. And then it will carry on for the next shift. I think
That's good. Thank you very much. Very good.